This video is an introduction to functions of several variables. We'll start with a definition here. So for this definition, we'll say a function of two variables assigns to each input pair which I'll say x comma y, ordered pair, exactly one output number, which I'll call f of x, y. And really what we're going to talk about here is essentially, things that would be in 3 dimensions. We won't get too far into it in this course, talking about the dimensions, but the idea is that, if you had an x and y axis, think about like this piece of paper being flat, you could find an ordered pair that was on the x and y axis, and then this function f of x comma y will assign a value, which a lot of times we'll call z, which represents kind of like a height. So you would have, 3-dimensional space, so x comma y would be flat, and then you'd have a, like with a pen going straight up and down through your paper would give you a z-axis, and that would be the height above which this point might occur. If you're not used to seeing it in 3 dimensions, think about it like this. Like this would be your x-axis, this would be your y-axis, and think of that as being flat, and then the z-axis is the one that's going straight up and down through here. So xy is like your plane that you have as your xy plane, and then z would be the height at which that point occurs. So f of x comma y sometimes is called z equals that. But it's thinking of it in 3 space. For an example here, let's just do a couple. If I said given f of x comma y equals, we'll say it's y squared plus 2xy raised to the 3rd power, and we'll say find the following. So we'll find, for the first one, I'll say f of negative 2 comma 0. So all that's saying is that you have 2 inputs. Negative 2 is the x value, 0 is the y value, and we're going to substitute in. So we would be substituting into here. We would have y squared would be 0 squared plus 2 times x, which is 2 times negative 2 times y, which is times 0. Remember, these written next to each other means multiply. And then this whole thing in parentheses raised to the 3rd power. And then all we're doing is simplifying. Simplifying this into with 0 plus 2 times negative 2 times 0. Well, that's going to be 0. So it's 0 plus 0 to the 3rd power, which really just makes this whole thing 0. So we would actually be at the origin at 0, 0. Well, not the origin, I shouldn't say that. You're at the point negative 2, 0, right? So the x value would be negative 2, the y value would be 0, so you wouldn't go up or down, but then you wouldn't go up or down for the z-axis either, so you'd be right on the x-axis, or in the x-plane. But the important thing is to know the value you get is 0 out. If we're looking at just another one here, if I said I had f of 3 comma 2, again we're just substituting in. Substituting in for y, we'd have y is 2 now, so it'd be 2 squared plus 2 times x, which is 3, times y, which is 2, all raised to the 3rd power. And simplifying this, you have 2 squared on the inside of here, which is 4, plus we have 2 times 3 times 2, so 2 times 3 is 6, times 2 is 12, so 4 plus 12, this quantity cubed. Make sure when you do this, you recognize that you should be simplifying the 4 plus 12, adding them together first, then raising the 3rd power. You can't raise each piece to the 3rd power because it's a sum. So you'd have 16 to the 3rd power. And if you evaluate that, you can use your calculator, it comes to 4096. So the ordered triple would be 3, 2, 4096. Right here, the ordered triple would be negative 2, 0, 0, if you're looking at a point on the graph. So it's basically substituting in. It's really not anything you haven't done before. We'll just do one example here with an application, but it's really, pretty much the same thing we just talked about. If I said, for this example here, a formula for approximating surface area in meters squared. Remember, area has units squared. So in meters squared of a human is given by, when I talk about the surface area of a human, I'm really talking about like their skin, right? So it's given by this formula, and they use this function they call S of H comma W. So those are the inputs, and it's equal to the square root of H times W over 60. Right, so that's a formula where H is height in centimeters, W is weight in kilograms. And the question will say use. Right, so use this to approximate the surface area of a 165 centimeter tall person who weighs 80 kilograms. So they're giving you a formula here, right? They're asking you to use it to approximate really the surface area of a human, like so the amount of skin they have. And they're telling you, the person's height and their weight, and you should be able to use the formula. So what they're really saying, right, for our solution is they're saying, okay, find S of H comma W. H in this case, well, it's the height, it's 165, comma W, which is the weight in kilograms. They told us that was 80, so we're looking for S of 165, comma 80. Which we're just substituting in, right? So this is going to equal the square root of H is 165 times W, which is times 80. Right? And if you want, you put those in parentheses. All over 60, recognizing that the square root is just in the numerator, not on the 60. And you can use your calculator to approximate this. If we went taking the square root of 165 times 80, close the square root up, and then divide that value by 60, we get 1.91485. We'll approximate just the two places, so 1.91 we'll say. So this is approximately 1.91. Remember what the units are on this? They said this is surface area in meters squared, so it's 1.91 meters squared, or you could say square meters. So that's the surface area for a human who is 165 centimeters tall and weighs 80 kilograms. Basically, this was just making sure you understand how to substitute in. All right, so this section is really short. It was really just making sure you understand, how to evaluate functions. On the next sections, we'll talk about how we use these functions of several variables with partial derivatives.